All right, we'll be starting section 1.2 today. Topic is random samples. And here's all the learning targets that we will get through. We might not totally finish the last one, but we'll see if we have time to get through these sampling methods, okay? All right, so to begin, I want you to read page 13. And as you read through it, you'll find a simple random sample definition that I want you to record in your notes. And then we'll continue from there. Pause now. Okay, so they typically use N for the sample size. So if I'm going to sample 10 kids from the school, that's the variable they're going to use for that. Okay, sample size. And every sample has the same equal chance of being selected. All right, that doesn't always end up being proportionate. So that's an important thing to remember about simple random samples. They said they got 10 cats, 10 dogs, and they're going to grab a random sample of size 6 could consist of all cats. That could happen. Or maybe I have 4 and 2, right? It doesn't always have to be proportionate and be 3 and 3. Okay, so simple random sample allows for some disproportionate samples. Okay, all right, let's go ahead and take a look at this guided exercise 3. Go ahead and read through that setting, and then we'll walk through it together. Okay, all the numbers have an equal chance of being selected. So is the number 25 is likely to be selected in the winning group of 6 numbers as the number 5? Sure. Yes. Since this is an SRS, we'll use SRS for simple random sample. Okay. Each number has an equal chance of occurring. Okay. Part B, could all the winning numbers be even? Sure, we can see that. You'd expect it to possibly be a little mix of evens and odds, but it's definitely possible that all winning numbers could be even. So yes, since all samples of size 6 have an equal chance of occurring, this could happen. All right, your friend always plays the numbers 1 through 6. Could she ever win? As odd as it may seem, this is just as likely as any other combination of 6 numbers. Okay. Usually they're mixed up a little bit, but technically it has the same odds of winning as any other random combination you think might happen. Okay. All right, and that next little example goes over that disproportionate thing I was talking about. So let's take a look at this. Is this an SRS or not? So 400 students in the freshman class at a big high school. 200 happen to be female and 200 are male. School officials want to send 10 of each gender to a conference so they take an SRS of 10 females and an SRS of 10 males. Okay. Well, SRSs are supposed to allow for some disproportionate samples. So basically, they want to send 20 people to a conference. But if I put all 400, assign them numbers, and throw them in a big lottery ball, I might have 12 females and 8 males just by chance. That could happen, right? Does that make sense? All right. Now, there's nothing wrong with sampling like this if they want to keep the proportion the same, especially since it's 50% anyways in the class. This actually has a name to it we'll get to in a little bit, but I'm going to throw it at you now. It's called a stratified sampling. If you create groups ahead of time and then do an SRS within each group, it has a different name. Okay, stratified sample. So here we go. Kind of in your own words, I change up the numbers here. So no, an SRS should allow for samples like, and I gave an example, right? 11 females or 9 males, or 15 males and 5 females. That could happen in a true SRS. Okay, after you get done writing that down, continue the reading halfway on page 14, below the example. Let's start reading that, and then we will go right into example 3. So I'll give you about a minute or 2 to read that, and we'll continue on. Okay, these, just like they explained, these are just random digits. If you don't have to open up your book right now to this table in the back, but there's this appendix of just that. It's called a random numbers table. And these numbers are just randomly in a hat or use some type of computer just to generate these numbers. They put them in clusters of 5 just so they're easier to grab, I guess, if you're using the table. But sometimes we'll use this to just start at a random line and then use these random numbers to help us draw an SRS. So for example, to get a random sample of 30 cars from a population of 500, what you'd want to do is assign all cars a number from 1 to 500. And then what you do, pay attention to this, I got to grab 3 numbers at a time. So my first random car would have to be 3 digits. So it would be 992. Okay, 992 is not in my range from 1 to 500, so I just skip it. I go on to the next block of 3. 815, not in my range. Bye-bye. 964, not there. Sometimes it takes a little while. So this is the first car selected, 15. Okay, does that make sense? And you just keep going until you get 30 cars. The next one is car 221. All right, so you can always change your size depending on how many digits you need. If I only had 99 cars, I'd be grabbing 2 at a time. Okay, so you choose the size you need to based on your sample size. All right. And then that's exactly what they did over here. 992 is the first one I showed you. See that they're just doing groups of 3. We throw out the ones we don't use and we use these ones. Okay. There's also ways we can use our calculator. We'll get to that later, but that's one way to do it. Okay, and let's continue on. How to draw a random sample in the procedure. And that'll lead us to example 4. You've got a definition to fill in here, simulation. So read through this procedure and then write down simulation before we get to example 4, which is a simulation. All right, so I want you to try to use this random table. So what I'm going to have you do is I want you to find the appendix in the back, and I'm going to give you a row to start at. So we all have a different line of digits. And you're only going to need the first 10 single digits because, for example, I've got an example of a row here. 4, so what is that going to be assigned? 4 is supposed to be an even number, which even is going to be heads. So then just above it or below it, I'll just put, okay, heads was the outcome. Another even number, heads. And then that's an odd one, so it's tails. All right, so I want you to create a little simulation on your own. All right, so at home, just go back to the appendix and choose a random line to start at, write your 10 digits, and then do the simulation. All right, looks like most of you are through the simulation now, so we'll summarize this. I was starting to put the outcomes below it, but I guess that's where part C, that's what that space was for part C. So here's the outcomes for row 10 that I had. Odds are tails, evens are going to be heads. So here's the result of my simulation. I had 6 heads, 4 tails. You may or may not have had that outcome because it's a simple random sample. Okay, it's probably going to be close to a 50-50 split. So if you start in a different block and row, which happened because we did different rows, will you get the same sequence of outcomes? So in your own words, something like this. Getting the exact same sequence could happen, but it's unlikely. Especially if they said sequence, right? In this exact order. That's probably very unlikely. It's a little more likely to maybe get a common outcome or results. Pretty unlikely to get the same exact sequence. Okay. Okay, next thing I want to look at is on page 16. It says tech notes, but it talks about sampling with replacement. So I want you to dig into that paragraph and find the definition for sampling with replacement. Okay. Okay, so sampling with replacement. So when a number object is selected for the sample, but is not removed from the population. So it's maybe put back in there. So here's an example of, they said number, but it's also like an object, like this example here of a deck of cards. So draw a random card from a deck and then replace the card, reshuffle, draw again. That's sampling with replacement. Kind of keeps the odds back as the same if we're doing a probability problem on this. Do this when you want to keep the odds the same, if we're creating some type of simulation. All right. We're also going to see the phrase sampling without replacement. So if I were to piggyback off that last example, it's sampling without returning the individuals into the sample space or without putting the card back in the deck. Okay. I gave also another example, that car example. If you select car 15, we aren't going to select car 15 twice. So if that number comes back up, we skip it. Okay. Okay. Sampling techniques. I'm going to save the rest of this for tomorrow. There's a lot going on with sampling techniques and a lot that we need to discuss with that, and that'll take us almost to the end of the hour. So we need to save that for tomorrow. That's it for today.